Alright, now we're going to take a look at number 100 on page 128, where we've got the function equal to secant x, and we're being asked to find the second derivative. So to do that, we first have to find the first derivative. And hopefully you remember this one, we did this in class. The derivative of secant x is equal to secant x times tangent. So that one you don't have to do much work on. It's something you just have to remember. You don't have to do the quotient rule every time. You should have that memorized. Tangent x. Alright, and now we have to take the derivative one more time, and this time it's going to get a little bit more complicated, because now we have to use the product rule because both of those pieces of our function are multiplying by each other. We have one piece here and one piece here. So our product rule, we'll take the derivative of the first. So again, derivative of secant x is secant x times tangent x. That's the derivative of the first times the second, which is again tangent x. I know it looks kind of funny to see tangent there twice. Then plus the derivative of the second, so the derivative of tangent x, which hopefully you also remember is secant squared x, times the first, which is again secant x. We have a lot of repetition in this one. Make sure you keep it all straight. And then we need to simplify this a little bit. Tangent x times tangent x can become tangent squared x, secant x in front of that, plus secant squared times secant is secant cubed x. Kind of an odd one, you don't see that very often. Although I see both terms here have secant, and so I think to simplify this even further, we're going to want to factor that out and put it outside some parentheses. So we'll have secant x, and we can only take out 1 because the first term only has 1, times, and then we'll be left in the first term will become tangent squared x plus, and if we take away a secant from the secant cubed, it becomes secant squared x. And I'll close the final parentheses there. And I believe that's as far as you can go for the second derivative in simplifying. So we'll call it good right there. And we have our second derivative. Hope that helped.